So handout number 7, exponents with scientific notation, handout number 7. So here we're estimating quantities. Now, what I want you to understand about estimation is an approximate value. It's not the exact same value. It's approximate. So we're estimating, it says very large and very small values using powers of 10. For letters A through C, we're going to round those numbers to a given value, and we're going to rewrite that value as a single digit. That means one digit times the power of 10. So we're going to write it in scientific notation. So if we're going to round a number, one thing I want you to remember that when you write this up top, this is when rounding. You're going to look to the right of the number being rounded. And if the number is 5 or more, increase the number by one value. If the number is less than 1, not less than 1, if the number is less than 4 or less, leave the value the same. We always say 5 or more, raise the score. 4 or less, let it rest. So we say 5 or more, raise the score. 5 or more, raise the score. 4 or less, let it rest. And hopefully these are some pointers that help you remember how to estimate large quantities. So let's get into it. All right, let's look at the value of A. If we want to round this number to the nearest 10,000ths place, this is our ones, tens, hundreds, thousands, 10,000ths. We want to round to the nearest 10,000, so I'm going to look to the right. That number is 4 or less, so we're going to let it rest by rounding this number to 20,000. If you want to convert this number to scientific notation times the power of 10, remember, scientific notation is a number between 1 and 10 times the power of 10. I can write this as 2.0 times 10 to the 4th power. Letter B, our number 8 is where we want to round. So we're going to look to the right of 8, which is a 7, which means our 8 will round up to a 9. So we round this as 1, 2, 3, and place a 9. That means everything behind it will drop off. And to write this in scientific notation, a number between 1 and 10 is 9.0 times 10 to the negative 4. Letter C. Letter C, we have 6 million. We look to the right of that. That number is 5 or more. So this rounds to 7 million. Scientific notation is 7.0 times 10 to the 6th power. It says estimate the following values by rounding and rewriting as a single digit times the power of 10. So again, we're rounding to the nearest whole number. Look to the right. That number is 4 or less, so we're going to let it rest. So this is rounded to 700,000, which is 7.0 times 10 to the 5th power. Number 2, our 5 is our digit that we want to round. So we're going to look to the right. That number is 5 or more, so we're going to raise the score. That means 5 is going to become a 6. And you're going to keep the number of zeros in front, which is 1, 2, 3, 4, 5. And raise that to the 6th power. You have 5 zeros to the 6. 5 zeros and 6 is the place value for tens, hundred, thousands, 10,000, 100,000, millions. So we read this as 6 millions. To write this in standard form, it's already written, but then it says we're going to rewrite it as a single digit times the power of 10. So this would be 6.0 times 10 to the, how many times we moved it? 1, 2, 3, 4, 5, 6 power. Number 3, we look at the 1. We're going to round that to the nearest whole number. So that'll be 10 million. So this is 10 million, and write in scientific notation. It's 1.0 times 10 to the 7th power. Number 4, do 7. It says you're going to apply estimating with powers of 10 to answer each question. Be sure to show your work. So in 2015, the world population was about 7,390,000,000. In the same year, the population of the country that Red lived in was about 6,926,000. It says give an estimate of the world population in 2015 using powers of 10. So the world population was 7,390,000,000. So to write that as a single digit in scientific notation, we're going to look at the 7. And to the right of the 7 is a 3. So that's 4 or less. We're going to let it rest. So this estimated to 7 billion. And then to write this in scientific notation, we have 7 times 10 to the 9th power. Letter B, it says give an estimate of the population of Red's country in 2015 using the power of 10. So we have 6,926,000. I look to the right of that digit is 5 or more, so raise the score, which means 6 will now increase by 1 and go to 7 million. And to write this in scientific notation, it's 7 times 10 to the 6th power. Letter C, it says approximately how many times greater was the population of the world in 2015 than Red's country. Okay, first we have our world population. And our world population will be divided by Red's country. Now, what in the problem lets you know that you are dividing? If you said how many times greater, you are correct. How many times greater means to divide. Okay, so we look at the world population. The world population was 7 billion, which is 7 times 10 to the 9th. Red's country was 7 times 10 to the 6. And now we're dividing because of the fraction bar. So 7 divided by 7 times 10 to the 9 minus 6 is give you 1 times 10 cubed. So we can say that it is 1 times 10 cubed or 1,000 times greater. All right, next we're looking at the next page, which is numbers 5 through 7. Number 5 says Vincent's dad drives a car that weighs 3,980 pounds. A toy car in Vincent's toy box weighs about, it's 8,125 pounds. It said give an estimate of the weight of Vincent's dad's car using a power of 10. So Vincent's dad's car is 3,980. If I'm giving an estimate, I'm looking at the first digit, which is the larger place value. I look to the right. This is 5 or more, so it rounds to about 4,000. In scientific notation, that's 4 times 10 cubed. It said give an estimate of the weight of Vincent's toy car using the power of 10. So after we write our number, we look at the place value of our larger digit, which would be the one closest to the decimal. In this case is 8. We look to the right of 8 to round. That's 4 or less, so we're going to let it rest. So it's 800ths. And in scientific notation, that's 8 times 10 to the negative 2 power. Letter C, it says approximately how many times heavier. Here we go again. How many times heavier? Like the last one's how many times greater. So this should indicate to divide the problem. So we want to set up the problem. It says how many times heavier is the car that Vincent's dad drives than Vincent's toy car. So we have Vincent's dad's car divided by the toy car. So Vincent's dad's car is 4 times 10 cubed. And the toy car is 8 times 10 to the negative 2. Here we want to divide. Eight divided into 4.0. It doesn't go. Bring up your decimal, but 8 goes into 45 times. No remainder. And then our bases are the same, so we're going to keep the base and subtract the exponents. This gives me 10 cubed plus 2, which is 10 to the 5th power. So now in scientific notation, we have 5/10 times 10 to the 5th power. We need to put in scientific notation, so we make this number larger by 1, make your exponent smaller by 1. So this gives me 5 times 10 to the 4th power. Number 6, the diameter of a grain of sand measures about 46/10,000, while the diameter of a dust particle measures 500 thousandths. Give an estimate of the diameter of a grain of sand using the power of 10. Remember, the grain of sand is 46/10,000ths. We want to round this 4 by looking to the right. That's 5 or more, raise the score. So this is actually 5 thousandths. And to put that in scientific notation, that's 5 times 10 to the negative 3 power. And that's in inches. Next is give an estimate of diameter of the dust particles. So we write the dust particles. So 500 thousandths. You move the decimal in scientific notation, 5 times to the right. So this equals 5 times 10 to the negative 5th power. And that's in inches. For letter C, it says approximately how many times larger. How many times larger means to divide. It says how many times larger is the diameter of a grain of sand than the diameter of a dust particle. So we have a grain of sand divided by the dust particle. So a grain of sand is 5 times 10 cubed to the negative cube. And the dust particle is 5 times 10 to the negative 5th power. So now remember, to solve this, I'm going to divide my constants. And I'm going to keep the base and subtract the exponents. This 5 divided by 5 is 1 times 10 to the negative 3 plus 5, which is 1 times 10 squared. So to answer the question, 1 times 10 squared is also 100. So you can say 1 times 10 squared or 100 times larger. Number 7, it says a snail in Lawrence vegetable garden is traveling at a speed of 300 miles per hour. An airplane flying above Lawrence's house is traveling at a speed of 575 miles per hour. Give an estimate of the snail's speed using the power of 10. So the snail speed, in the beginning we have the speed of the snail. So the snail speed is 300. In scientific notation, that's 3 times 10 to the negative 2. And he traveled in the miles per hour. B says give an estimate of the airplane speed. So the airplane speed is 575 miles per hour. So in scientific notation, it says an estimate. So I have to round this. So I'm looking at the numbers in the hundreds place. I look to the right. It's 5 or more. So the 5 becomes 600. Which also equals 6 times 10 squared miles per hour. Letter C says approximately how many times faster is the airplane traveling than the snail? How many times faster is similar to what we said about how many times greater. So we're going to write our word problem and set it up as we would any other high stakes testing word problem. So it says approximately how many times faster is the airplane traveling than the snail. So we have the airplane and the snail. So the airplane, we already noticed that that's 6 times 10 squared. And the snail is 3 times 10 to the negative 2. Dividing our numbers, that's 6 divided by 3. times 10 squared divided by 10 to the negative 2. 6 divided by 3 is 2 times, keep the same base, subtract the exponent, so that's 10 to the 2 minus a negative 2, which is 2 times 10 to the 4th power. So if it's 2 times 10 to the 4th power, or in standard form with a decimal 4 times to the right, so you add 4 zeros. The airplane is traveling 20,000 times faster than the snail. So 20,000 times 20,000 times faster. All right, so that is our lesson for today. I do want you to go to homework 7, and you're going to work out all of the problems here. I did all of this already. It doesn't take a long time, but the statements that you mark false, you have to rewrite a false statement to make it true. Now, I want to see one for every single person. Please do not tell me that there are no false statements so that you can avoid doing this one. That's not going to fly. Okay? All right? So, good luck. I will see you all soon. And let's make it a great day. Thank you.